Hello everyone, how are you? I hope you are well. So after a long time, so from the today I am starting the new series of the video. Its name is the ST programming. Okay. So many people knows the ladder logic, how to develop the ladder logic. So if you already know the ladder logic, so how we can convert the ladder, no, sorry, not convert, how we can make the ST programming मतलब कि structure text programming or SEL whatever you say from the ladder. So I will explain you step by step, and I also make the ladder programming and how this structure text program will become from the ladder, that I also explain in this series. Okay, so today we will start from the basics. Okay, so here no any theory, directly practically. Okay, so it will be easy, and maybe it's not become a boring session. Okay, so just start from the ladder. Okay, so here I am adding one ladder. First of all, we define all tags. Okay, we define the all tags. Okay, so here these are the some tag, but I am adding new ones. Okay, so for example I am adding here tag is input, input1, input1 like that, input1. Okay, address I00 dot. Okay, then input2, input2. Okay, input3, input3, one more, input4. Okay, so I think this is okay now. For the output, so op1 means our output one. Okay, so address is q0 dot 0. Okay, percentage q0 dot 0. Okay, then op2 means output 2. Okay, so address 0 dot 1. op3, op3. Okay, op3 q02 and op4. Okay, only this input output is enough for us. Okay, okay, so this is our tag. Everything I will show you in the last in simulation mode, but first how we can design this from the ladder to ST. Okay, actually ST is a very easy language in form of the writing. Okay, but whenever we need to some calculation, mathematically calculation, so that time ST is very important. So scanning time passed. Okay, and in many servo amplifier applications, those are also using the ST language. Okay, okay, now for example I have one input and I have one output. Okay, so my input is input 1. Okay, then output is op1. Okay, so this is my ladder logic, and using in form of this ladder logic I want to make the uh, ST programming. Okay, so right click. Okay, insert in SCL. Okay, you can say SCL also, no problem. Okay, now this is the input and this is the output. In this ladder logic, the input side is left side and output side is right side. Okay, but in the SCL language or ST language, whatever you say, okay, in this the output side is always left side. Okay, and input side is always right side, means data will move from right to left. Okay, in ladder logic data is moving from left to right, but here data will move from the right to left. Okay, okay, now this is my input. Okay, so here no any address I define, directly the tag name. Okay, so tag name and double inverted comma, it is automatically will present. Okay, So this is my output. So this output I'm writing here, and then equal. Okay, this is the assignment operator. Okay, use the assignment operator, and then input. Okay, input one, input one. In last one, this is more important. Do not forget to make this column. Okay, so this is up. This is the logic like S. Okay, but here the output is 0, but we cannot use the same output. Okay, so we also need to change the output. Okay, okay, so this is our logic. Okay, no any error means logic is correct. Okay, so this is our first. Okay, now next, for example, I have one more ladder, uh and operation. Okay, and operation, this is my and operation. Okay, and one more and this is my end operation. Okay, so and one more thing I am adding here, one more operation. Okay, this is our operation. Okay, so this is my input. Okay, I'm going fast because you already know the what is the parallel connection and what is the series connection. Okay, and or like that. Okay, this is also input. Okay, here I'm using input 3, and here I'm using the input 4. Okay, now how to write this in ST programming. Okay, here I am checking output 2. Okay, oh sorry, output 2 already is used, so I'm using the output 3. Okay, okay, so this is our ladder logic. So how we will write in the SCL or ST. Okay, so here I am adding, right click, insert the SCL. Okay, so I'm just deleting, no need. Okay, so here you can see here the our output is op3. op3 is our output. Okay, but I will not use the op3 because the due to same address. If we are using if I use this op3, so then need to delete this because it is not possible to function both the output in output condition. Okay, so here I'm using the op4. Okay, op4, then equal to. Okay, now you can see here, this is the condition, this is the condition of AND. So between I0 dot 0 means input 1 and input 2, it is a AND condition. Okay, so in bracket, okay, my tag name inp. Okay, and for AND condition directly use AND. Okay, I think you already know AND or like that. Okay, then input 2, then input 2. Okay, so this first condition is completed. Okay, this first condition is completed. Now second condition is, this is connect input 3 and input 4 is connected with the AND gate. Okay, this is the AND logic. Okay, so I will make another bracket for this inp3 and 4. Okay, so inp3, okay, and inp4, inp4. Okay, but in between this AND logic and this AND logic, in between this is the ORing between this ladder and between this ladder. Okay, so this is the ORing condition. So this OR condition I will take here, I will add here. Okay, array, and do not forget this one. Okay, so this is our logic. So this is the AND. So this is the AND, input 1 and input 2 and OR between the two ladder, and this again this input is here. Okay, so this is the AND logic. Okay, so one more example I will show you. Okay, I am taking one input 1. Okay, and then input 2, and input 1 is parallel. Okay, so here one parallel I0.2. Okay, I am adding one more parallel with I02. Okay, so you will understand easily. I0.3. Okay, then output. Now output already you all our output 4 already used. Okay, so don't worry, we will use Q0.4. Okay, we can change the tag name OP4. Okay, OP4 already. Okay, not an issue. Okay, but here we will use another. Okay, so right click, insert SEL. Okay, I am deleting this. Now see here this condition. Okay, this condition for Q0 dot, I am using Q0.5 percentage Q0.5. Okay, okay, why percentage Q0.5. Okay, its name is tag 1. Okay, so this tag 1. Okay, I am rename this tag OP5. OP5. This is my tag name of output Q05. Okay, now this is my output here. Okay, then assignment operator. Then look at here, these three condition in between is the or condition. Okay, so you can see here in between the condition is or condition, so I will make one bracket. Okay, so input 1 or with input 2 or with input 3, input 3. Okay, but these are all in or condition, but this input is in and condition. Okay, so I am adding here and this is for the input 1. Sorry, input 2. Okay, input 2. Okay, and do not forget this operators. So this is our logic. Okay, so it's very easy, not an issue. Okay, so this is the example, but here we not add the not condition. Okay, so how we can write the not condition? In not condition, I will show you how we can write the not condition. So I am adding one more ladder here. Okay, I am making one more ladder in not condition. Okay, this is not condition and this is my output. Okay, so I'm taking here input 1 and this is input 2. Okay, in not condition, and this is my output 6, Q0.6. Okay, now in this case what we need to add in SEL means here already uh, normally open contact. Okay, so first I will add this output here. Okay, so Q0.7 percentage Q0.7, it will automatic decide the tag. Okay, check 2 assignment operator. Now what is the condition? So this in between condition is AND condition. Okay, so I will add here input 1. Okay, input 1 and but here the condition is not condition. Here the condition is not condition. Okay, so in bracket I will add here not. Okay, not, and then space, then my tag input 2, and do not forget to add this one. Okay, so this is the condition for the not. Okay, so according to that you can make any conditions for the and or not. Okay, XOR. So some instruction, I hope some instruction is available, but we will check you one by one. Okay, so okay, so this is the condition, this is the not condition. Okay, okay, so this is the basic thing. Okay, so in this way you can make the ST programming. So and or XOR just need to write down only. Okay, so whatever the condition, that condition you want to write here. I'm adding one more things. So if you have many inputs, okay, many inputs, so all input need to add put 2, input 3, input 4, then input. Okay, only 4 input, and output Q0.7. Okay, so this is my sequence. So sometime we are making like we are adding something, means emergency. Okay, air pressure is okay. Okay, so this is my condition. Okay, so how we can develop this network number 8 in our SCL. Okay, so we can add here also, no problem. Okay, so first output Q0.8. Okay, I'm not taking same output address here, no an issue, but I'm not taking this one. Okay, okay, I think it is, oh sorry, tag 3. Okay, so for tag 3, so input 1 and input 2. Now input 2 is a NC condition, you can see here input 2 is a NC condition. Okay, so we will add here not gate. Okay, not. Okay, then and, then not. Okay, input 3. So in some case bracket also not required. Okay, and input 4, input 4. Okay, and do not forget this mark. Okay, so this is the convert from the this ladder to SCL or ST, you can say SC or STL. Okay, so check. Okay, there is no any error, means program is correct. Okay, so but here the problem is holding condition. So if you want to take the holding condition like that, what will be happen? No, it is okay, no problem. Holding condition means same output you want to use this Q0.7. Okay, so can we take here or take 3 like that? Okay, so this is our holding condition. So in this way you can take this holding condition. Okay, so this is the programming of the ST. Okay, so this is enough here. So you can do the practice yourself. Okay, so this language is also very easy. So this is the first means this is the first video of this ST language, but in next video I will cover the how to take the timer, how to take the counter operation. Okay, so I will show you the timer and counter operation, then bitwise operation, set reset operation, that all thing or everything I will be cover in this next session. Okay, so many topics I have means then after arithmetic operation and many instruction that we already perform in the ladder, that instruction also will perform in this ST programming. And you know the ST program have different statement like if else condition, you can see here if condition, case condition, for loop, while loop. Okay, so this everything I will be covers in this ST programming. Okay, so this is the first video, so I will limited of this limited content in this. In the next video I will add the small means or add more content, and it will be easy for you for understanding and everything. And if you have any query regarding the programming, so you can drop the message, means you drop the comment in the comment box. Or if you like this video, please do not forget to like and share, also share these videos to your friends group or any colleagues, so that also need to learn the ST programming. Okay, so thank you so much everyone watching this video. We will meet you in the next session. Take care and bye.